Hi, in the previous video we introduced our pandemic class, which is now the main thing that really takes care of almost everything. So in our Pygame loop, or right before it, we create our pandemic, and then in the Pygame loop, it not only says run pandemic, and that's really everything that's happening there. So if we run this, we now have our animation right there. If we press escape as before, we can exit out of this. So before we'll now move on, I'll just add some additional key controls here that I really like and that I think make the experience a bit more, a bit more interesting here. So let's also implement the return key to restart with a new pandemic. So how do we do that? So if event.key is equal to pygame.uppercase k underscore return, well, in that case, we'll say pandemic is equal to pandemic. So here, we'll just be creating a new pandemic, okay? And another thing that I like to do is to have the ability to pause the animation. And we can do that by creating a new variable up here that I'll call, not animating, we already have that, but pausing is equal to false. So we set that, it's a Boolean variable to false. And then down here, we'll just say, if not pausing, and only then are we executing all of this up until here. Now the user interaction will still be tracked because, well, if we indented this as well, and the code, not the code, but the execution or the code is always being executed, but if the animation was paused and the user interaction would no longer be tracked, well, in that case, how could we unpause? So we must not indent the user interaction part that's being tracked, but we indent, the background color running the pandemic and then updating the screen and the clock and so on. Okay, so let's just indent that with pausing. Now let's use the the space bar to pause the animation. So space bar to pause the animation. Now, and actually, we'll also use the space bar to unpause the animation. So that's also important here, okay? And we do that using event.key is equal to pygame.uppercase k. Now simply space. And we'll just set pausing is equal to not pausing. So it works in both directions. If pausing is true, spacebar will set it false and vice versa. And then it might also be nice if the return key, so say the animation was pausing and hit return, if it, restarted from there. So let's set pausing to false just to make sure that, we always start with a new pandemic that, is, or the animation then also restarts. Let's just try that. And I'm also going to get rid of this. Everybody's already infected at once. Let's go back here to the patient 0, patient, not patient, self.people 0 get infected with self.infect, recover time. There we go. The person has already recovered. That doesn't matter though. What's important here is that I can now press the space bar and here's the recovered person. The animation is now on hold. I can press space bar again and everything is moving. And if I hit return, the animation restarts. And here we now have 2 or 3 people that have contracted the virus. I can unpause this, and now here with this run of the animation, there's now an actual, maybe it's an epidemic at this stage, but it's not going to be much longer until this is an actual pandemic. And again, we have that annoying problem of, the frame rate just dropping and dropping further and further. And now is the time that we are going to fix this. So here we go. I'll go into the pandemic class. And notice here how we had this function infect people. I'm now going to call this, I'm just going to call it slowly infect people. And now we'll have our function that is, just infect people, where we will now rewrite all of this, but with us making use of the grid. So instead of looping through people, we'll now loop through the cells in our grid. So instead of typing for p in self.people, let's just go with for c in self.grid.cells. Okay, so yeah, let's loop through the cells. Now, if a cell does not contain a single infected person, we can just move on to the next. Okay, so move on if nobody is infected in that cell. You'll just retrieve the health states of every person within that cell. So p.state for p in c.people. That's now the health states of everybody. So now we're going to make a simple count. So if states.count infected, that is equal to 0, well then we'll just use continue. So continue, it just says go on with, the next iteration of the loop, which in this instance corresponds to, move on to the next cell. Okay, now if that is not the case, so that is there is an infected person, we'll now create lists of all people, then of all infected people, and also all healthy people in the area. And within the area, I mean this 3x3 grid. So instead of having this one cell, we're only this one cell, we're now also looking at the other 8 cells surrounding that cell. So this is what I mean with the area. So maybe we'll just say in the 3x3 area. So that should make it clear. Okay, so people in area, we'll define a new list here, and that'll be an empty list for now. And now comes a very critical part here. Now, how do we know what cells are surrounding cell C? Well, to do that, we'll say for index, so for every index in our cells object, in our grid cells object, for index it's c.get, and here we'll now be calling a function that we have not defined yet, get neighboring cells of, self.grid.n rows and self.grid.n calls. And let's just put a pass here for the moment, and let's think about this. So I've just called a function that's called get neighboring cells. So within C, within every cell, within the cell class, we will now create a method that, when given the total number of rows and the total number of columns within the entire grid, can produce the indexes of the other cells that are surrounding it. So with this information here and there, cells will, from now on, once we have defined that function, be able to tell what their neighbors are, who their neighboring cells are. And with that, well, we can then determine the people in the vicinity of that infected person. So now we go back up to the cell class. That is all the way up here. Now, that was not supposed to happen. Now I've got to go back up here. Grid and cell. And here we will now define a new method, which I'll call get neighboring cells. So self and the number of rows and the number of columns. How do we do that? Well, let's first get our own index. So self.row times self. Not self dot in this case, we're just passing this as a parameter. So number of columns plus self dot the column. Okay, so the cell knows its own row and its own column, but it does not know the total number of rows and columns in the grid. But if we give it this information, the number of columns, it can figure out what its own index is within the grid. And now, well, let's compute the other indexes, and I'm simply going to be calling them north, south, west, and east, and then also, we must not forget, northwest, northeast, southwest, and southeast. And then we'll return a list of all of these indexes. But let's define one after the other. we begin with north. So north is the index of the current cell, and then we're moving up one row. So we must subtract the number of columns in the grid, because that is, well, the number of columns within each row. And if we subtract this number of columns, we are effectively subtracting one row. But there's a problem here. What if we are in the very top row? Well, if we are in the very top row of the grid, there is no neighbor to the north. So we must make sure that in that case, our function will return none. So if self.row is greater than 0, that's when we are doing this, what is our neighbor to the north. But if not, well, then we'll just return none, because if our own row, so our cell, our own row is not greater than 0, then we are in the top row, so there is no north neighbor. Now with our southern neighbor, it's pretty much the same thing. Instead of minus number of columns, we say plus, and instead of checking whether we are greater than 0, we're now checking whether number of rows minus, whether we are less than the number of rows minus 1, and else it's a none return. Okay? With west and east, same thing, but instead of subtracting the number of columns, we'll simply subtract 1. So if we go west, we're just going back one index. And here we must check that self.col is greater than 0, else none. Jeez, I'm using lowercase letters here. Now with east, same thing, index but plus 1, if column again is less than the number of columns minus 1, else none. And with northwest, northeast, and southwest and southeast, we now simply have to combine these statements from before. So here we'll say index minus the number of columns minus 1. We are going up and to the left. If, and now we have to combine the two statements, the two conditionals, self.row is greater than 0 and self.column is greater than 0, else none. So what we've done here is we said we are going to take this part here, minus n cols, and then minus 1. And on the right-hand side of the if statement, of the if operator here, we'll say self.row greater 0, which is what we had up here. And then self.column is greater than 0, which is what we had down here. And then, well, it's just else none. Now we'll do the same thing with northeast. So northeast is index minus n cols, but now plus 1. And then I think I should start copy pasting this a little. Paste this, but now we have to adjust this part over here. So with, instead of northeast, it's not, well, instead of what we did with northwest. So here, well, we still must not be in the very top row, but here it should now say self.column is less than the number of columns minus 1, which is what we had with east. Okay? So, now, south means index plus the number of columns, and then minus 1 if, and so on. So I'm just going to copy paste this, but change this to a plus. Self.row is less than number of rows minus 1, and so here we can copy this. This is just checking that we're not in the southernmost row already, and self.col is greater 0, else none. And here self.column is less than the number of columns minus 1, else none. Wow, that's a long line here, a long line of code. And then now we can return I for I in now a list index, where we're returning our own index once more, north, south, east, west, northwest, northeast, southwest, southeast, then if I. So what this list comprehension here is doing is it's saying, well, I got this list of, neighbors, including myself, and I'm going to be looping through them, but only include these indexes if they exist. So if this is a none, we are not going to return that. So it's returning the list of all indexes that actually exist. And this is the get neighboring cells function. So now we can go back down here into our pandemic class, where we have the new infect people function. And now we have defined this class, this method, and now we can make use of it. Okay, right now we only have an empty list here, but now we are looping through all the indexes in that get neighboring cells return. And now we'll just add that to the people in the area. And remember, this is only returning indexes while we are interested in people. So we must convert these indexes into people. And we can do that by saying self.grid.cells, add that index location, and then .people. So from all of the cells or all these indexes, we're now retrieving the corresponding cells and then the people within those cells. And now we're also interested in, how many of these people are infected. And then we'll say P for P in, this is supposed to be 4, P in people in area. And now if P.state is actually infected. Now we do the same thing once more, but with healthy people. And to do that, we'll just change infected here into healthy. Okay, now if the length of all healthy people is equal to 0, well, that is the case, we can continue and move on to another cell here, okay? And now we'll loop through the infected people and then the healthy people. So this is basically pretty similar to what we had before with our slowly infect people functions. You're looping through people and then through the healthy people. So first infected people, then healthy. But now we are only considering people in this area of the grid and not everybody. And this is the key difference here. So for I in infected people, for H in healthy people, we now compute the distance. I can just copy paste this from up here. So infected and healthy, infected and healthy. And if the distance is less than self.infect dist, and now we'll also introduce the the random element here as well. So if random.uniform 0, 1 is less than the probability of not death but catching the disease. So if that is the case, then the healthy person gets infected. So h.get infected, and here we'll now pass the recovery time. So I really hope that I didn't miss any indents and other stuff, any commas and the like. But if not, let's give it a go, because it should be working already. I mean, we renamed the existing function into slowly infect people, and now it just says infect people. So yeah, down here, infect people is now referring to the new method. So let's give it a go. And yeah, this is working. Unfortunately, no pandemic was started, so I'm just going to refresh this. Again, no luck here. Okay, I'll have to increase the time that people are until people are recovered. I'll make that 1,000 as well. So now this person here, yeah, should be able to infect a lot of people. And now there is already a lot of people being infected. You can see that the frame rate is still, somewhere in the 70s. And now we have almost everybody infected, and we still haven't dropped below 50. And this is really the beauty of the grid solution. And this is why the grid is so much more powerful. Now look at this. I'm going to pause this. Now almost everybody is infected except for those people that have already recovered from the disease. And we still have a frames per second rate of 58. I'm going to close this. And instead of, using the new function, I'm now going to go back to the old function. Where's that? Here, infect. And here now it says, let's go with slowly instead. So let's run this once more. We started at 120. Where's our infected person? Down here. The pandemic now starts. The frame rate drops. The frame rate drops further and further. Now it's below 50, now below 40. And okay, now this is getting painful to watch. It drops below 20 and so on. And yeah, you can really see how we just made this code more efficient. It was working before, but it was just not feasible. And now I'm not going to call it lightning speed because there's still so much room for improvement. So get creative, find even better ways than the grid approach, and weed out any other inefficiencies that I have left in the code. But we have now made for a far better animation in comparison to what we had before. So let's, quickly get rid of this slowly thing here. And yeah, given that we now have this super fast animation, we can go for 10,000 people here. Let's hit run, and let's watch the pandemic unfold. I mean, this is no... It's slow, I know, it's 20 frames per second, but with the slowly infect people function, this would not have been feasible at all. We could not have watched this, at all. It would not have crashed, but the computer would have been painfully slow. And yes, I think this is it for this video. There will now be, I think, maybe one final part where we will, instead of, making any additional changes to how the pandemic works, we'll have a look at summarizing the pandemic. So once a pandemic is over, we would like to have a look at some graph that summarizes how infections and how the number of fatalities evolved over time. And I think this will then be the last thing that we'll look at. See you in the final part.